Welcome to solverfy.
In this problem, we have three waves that we're going to add up to make an equivalent wave. And these three waves are 10 sine omega t, 15 sine omega t plus a phase of 30 degrees, and we're going to add all these up, forgot the plus, and 5 sine of omega t minus 45 degrees. And they want us to add these up using a phasor method. So what's a phasor? A phasor, try it over here, is just a vector that spins around with time. All right, so all these are like three vectors. You add them up together and you end up with a third vector that's spinning around in time. These phase shifts just mean that at time equals 0, they start off somewhere. They don't necessarily start off right here on the x-axis. They start off some given angle. And so when you add them up together, you just start off at a different angle. So these are all sines as opposed to cosines. And so actually, the way you do this is, since these are all sines, and we actually just care about the sine component here. We'll just call that the y component and the x component. Let me redraw that here. Here's the y component, and here's the x component. All right, so we might as well just call this the y component. The x component is the same thing, but it's going to be the cosines. So 10 cosine omega t plus 15 cosine omega t plus 30 degrees, and plus 5 cosine omega t minus 45 degrees. All right, and so you just add these like vectors. What's going to be constant in here is the phase shift and the amplitude. So what's the amplitude when you add two vectors up? Well, that's just the y squared plus x squared all square rooted. So the total amplitude is going to be square root of x squared plus y squared. So that means you have to square this whole thing. Let's write it like this. A squared is going to equal, and since it's the same at any time, well, you might as well just set t equals 0. So set t equals 0. And so now we have that a squared, so the x component is going to be 10, right? Cosine of 0 is 1, plus 15 cosine of 30 degrees, plus 15 cosine of 30 degrees is root 3 over 2, and then plus 5 times cosine of negative 5 degrees, that's 1 over root 2, and that's squared. And now we have the y component plus the y component, 10 times sine of 0, that's 0, plus 15 times sine of 30 degrees. Sine of 30 degrees is 1/2, so that's just 15 over 2, plus 5, and then sine of negative 45 degrees is negative 1 over root 2, and that's all squared. And when you actually plug this in, you get that the amplitude is 26.8. All right, so let's just keep that in our back pocket. Now we have to find the phase. Well, the phase is given as tan inverse, right? Phase is just this angle here. So that's tan inverse of y over x. And again, that doesn't change. This is not the omega t part of the phase. This is the constant offset. So that's not going to change, so we can just plug in t equals 0 again. And so we get that this is going to be, so the y component, again, it's 0 plus, tan inverse. This is going to be 0 plus 15 over 2, and this is minus 5 over root 2, and that's all over the x component, which is 10 plus 15 times root 3 over 2 plus 5 over root 2. And when you plug all this in, you get that this turns out to be 8.5 degrees. And so that means that the whole thing, the whole wave is going to be a sine omega t plus the phase, and so that's going to be 26.8 sine, and it's sine because it's actually, right, these are all sines. This is actually the part we're adding up here. It's all the sines. And then we have the omega t, and then plus the constant offset, which is 8.5 degrees. And that's the answer.